All right, so now we're going to talk about solving for vertical asymptotes. So a vertical asymptote is basically if we take a limit as x goes to some value, we'll call it a. If that equals some number over 0, then that's going to be a vertical asymptote. Remember, anything over 0 is undefined. However, there's a little trick to this, and that's that some number cannot be 0, because if that some number is 0, then we have 0 over 0, which is again another one of our indeterminate limits. So anything over 0 is 0, anything over 0 is undefined with the exception of 0 over 0. That may be undefined, it may be end up being a number, it may be something else we don't know. That's why it's called an indeterminate limit. We can't determine what it is. All right? So if we get this condition, basically we have a vertical asymptote. So really, if we look at these examples right here on finding vertical asymptotes, all we're trying to do is find, okay, what x value sets this thing equal to 0? And if that x value doesn't make the numerator equal to 0 also, then we know we got a vertical asymptote. So right here, if we set x is equal to 0, we're going to get 0 in the denominator. So let's check the numerator. If x equals 0, this is going to be 0, that will be 0, and that will be -1. So we would have that the limit as x approaches 0 of f of x would be -1 over 0, which -1 is some number that's not 0 over 0. So therefore, x equals 0 is a vertical asymptote. All right, so now try to do this example on your own. See if you can figure out what the answer to this one will be. You should find that what's going to make this denominator down here equal to 0 is if x were to be the cube root of 3. So therefore, in this case, we would have the limit as x goes to the cube root of 3 of f of x would be equal to, if we plug the cube root of 3 up into here, the cube root of 3 squared would be 3 to the 2/3 minus 6 over 0. So 3 to the 2/3, that's some number, okay? So that's going to be some number over 0. So again, in this case, we would have x equals the cube root of 3 would be a vertical asymptote. All right, so try this one down here. If we do this one down here, you'll say, what makes the denominator equal to 0? Well, the answer will be the square root of 6, okay? So here we would have the limit as x goes to the square root of 6 would be, if we plug the square root of 6 in there, we get the square root of 6 cubed, which would be 6 to the 3/2 minus 3 over 0, which 6 to the 3/2 is some number. So again, here we would have x equals square root of 6 is a vertical asymptote. So in all three of those cases, we have vertical asymptotes. Now, the next thing we're going to look at in the next video is what's going to happen if we plug in the value, or the x value that makes the denominator 0. What if we get 0 in the numerator in that case? Well, if that happens to be the case, then we could end up with something called a hole, or in more technical terms, it's called a removable discontinuity. So we'll learn about that in the next video.